All right, I wanted to take just another minute since I'm gone and make sure that I go over a few examples so that you can see this one more time, and of course you have your notes as well. With single replacement, again, what you need to remember is that you're always going to have one single element by itself. In all of these examples, you have one element by themselves, and then you have a compound, which is two or more elements bonded together. So in all of these are single replacement reactions. That's how you can tell. You have this activity chart in your notes already. There are some examples that you're going to have throughout, whether it's in the next few days or on your test review or whatever, a few other elements that aren't included in this activity series. So make sure in your notes, grab those, and I want you kind of put a mark between potassium and calcium. CS is cesium, so that one would come after potassium, and barium, Ba, comes after cesium, and then it would pick back up with calcium and the rest of these. Now, again, what that activity series means is this tells you whether or not the element can replace the other element. So because zinc is a metal, the only item that it can replace is the other positive, which would be the other metal. So we're looking for zinc and lead. Find zinc, put a little mark. Find lead, put a little mark. Whichever one is on top, that is the one that should be bonded with the negative anion. If it is not bonded with the negative anion, then you have to replace it. It should be. So zinc is more active, and zinc right now is not bonded with the anion, and it should be. So you're going to need to fix that. Now, zinc on your periodic table is one of those transition metal exceptions. It always has a +2. So because we know zinc has a +2 and we know nitrate always has a -1, we can write a formula that would be correct. And then again, single replacement kicks out the metal, and so now that metal is by itself. So on the other side, you're also going to have a metal by itself with a compound. Now let's take a look at aluminum with hydrochloric acid. Aluminum is here. I'll try and do a different symbol. And hydrogen is here. Hydrogen, remember, has the positive portion of this. Hydrogen's positive, chlorine's the negative. So aluminum would have to kick out hydrogen since it's the positive. Aluminum is higher up on our chart, which means aluminum is more active, and aluminum should be able to kick hydrogen out of the way. So we're going to put hydrogen by itself. Now hydrogen's diatomic, so we have to make sure we do H2. And Al is a +3 charge. Just do a little side work here. Chlorine's a -1, so the formula should be AlCl3. Now, for your next one, same idea. I do want you to just take a second, though, because I don't believe this was in the original video. Remember that water is actually HOH. So when you're doing any type of single replacement, you need to think about it being broken apart into hydrogen and hydroxide. So now let's find silver, Ag, and find hydrogen. So silver's down here. Hydrogen, we've seen before. Hydrogen's higher up on the table, which means hydrogen should be the more active one, and it should be paired with your negative anion. Hydrogen is already paired with the negative anion. Silver is not active enough to kick hydrogen out of the way. So whenever you have something where it's already, the more active one is already bonded, you want to put an NR. That means no reaction, nothing's going to happen. Don't put any products because there's not going to be any. Last one, find sodium. Sodium's kind of high up here, little smiley face. And we have water, which is the HOH. So hydrogen is down here. See hydrogen a lot. Sodium is higher up on your periodic table, so sodium should be the one that's bonded with the negative, and in our example here it is not. So we would want sodium with a +1 to be bonded with hydroxide. So it's going to look like this, and then that means hydrogen is getting kicked out, and it's diatomic, so we need to put H2. It doesn't matter if you put the compound first and the element second, or the element first and the compound second. Doesn't matter. Either way, it's the same idea. So I hope that helps. Again, email me, get a hold of me if you have questions, but hopefully that maybe helped with you more examples.